Usually when we think about running a retail business, there is this heavy expectation of, well, human friction.
Right. Absolute.
You picture an entire ecosystem of people scattered across different departments. You have designers sketching concepts, buyers sitting in fluorescent lit conference rooms, debating what's going to be trendy next season.
Yeah, and copywriters trying to craft the perfect product description.
Exactly. And someone sitting at a desk manually dragging and dropping product photos onto a website backend.
It is a massive tangled chain of human decisions, manual effort, and inevitable bottlenecks. And
Yeah.
honestly, that friction is exactly what dictates the speed of commerce.
Which is why the commercial landscape we are stepping into today is just mind-blowing. Because right now, as you are listening to this deep dive, there is an online t-shirt store running entirely by itself.
Completely autonomously.
Right. It hunts the live internet for trending memes, it designs the original artwork, it writes the consumer-facing product descriptions, and it publishes the final listings to a live storefront.
All of it.
And it is doing all of this without a single human being pressing a button.
Which is incredible. We aren't just looking at a software tool that helps a human worker move a little faster. We are looking at a system that evaluates culture, makes creative decisions, and executes operational tasks entirely on its own.
And that brings us to the foundation of today's custom-tailored deep dive. This entire architecture was actually built by a developer named Shish just a few weeks ago, and they published an incredible technical breakdown on May 9, 2026, detailing exactly how they pulled it off.
The mission for you today, as you listen, is to really look past the novelty of this.
Yeah, it's not just a toy.
Exactly. Yes, an automated meme shirt store is a really fun concept. But the real value here is unpacking the exact architecture of this autonomous multi-agent AI pipeline.
Because it's a blueprint.
Precisely. If you can understand how these distinct systems communicate to sell a t-shirt, you can understand the future of enterprise automation. You can take these exact mechanisms and apply them to your own workflows, your own industry, and your own data.
So let's lay out the foundation of what Shish actually built here. At its core, this architecture relies on three distinct AI agents acting sequentially. You have the scout, the artist, and the publisher.
Right.
And they are all orchestrated by a developer tool called GitHub Copilot CLI, which basically acts as the manager keeping the whole pipeline moving. But before we get into what these individual agents physically do, we need to talk about how they're built, because the author made a very deliberate architectural choice right out of the gate.
It really did. It's a choice that actually runs counter to the instinct of a lot of developers right now.
How so?
Well, when you're building an automated system quickly, the temptation is to just pick one massive foundation model, like maybe it's GPT-4, maybe it's Claude, and just force it to handle every single step of the process.
Right, just a one-size-fits-all approach.
Yeah, but the deliberate decision here was to absolutely not use one single AI model for the whole pipeline. Instead, the models were chosen specifically based on task fit.
Okay, let's unpack this. It's like building a sports team. You don't just clone your best overall player 5 times and put them on the court.
No, you'd lose.
Exactly. Even if they are an amazing athlete, you need a specialized point guard with court vision, you need a center to lock down the paint, and you need a coach orchestrating the plays. One player, or in this case one model, simply can't win the game alone.
That is a great way to look at it. And if we connect this to the bigger picture, this is a vital lesson for anyone designing enterprise workflows. Forcing one model to do everything leaves so much performance and efficiency on the table.
It's just inefficient.
Right. Think about what this t-shirt store is actually doing. Analytical tasks, visual generation tasks, and procedural web navigation tasks represent fundamentally different computational problems. They require entirely different strengths.
So how did they divide the labor then?
Well, the developer used Claude for tasks requiring heavy reasoning, context parsing, and procedural coherence. Claude is fantastic at reading the room, so to speak.
Okay, makes sense.
But for the actual visual generation, they switched to OpenAI's image generation model, GPT-4o.
Oh, interesting.
Yeah, and the reason this wasn't a nightmare to code is because of that orchestrator you mentioned earlier, GitHub Copilot CLI. It natively handles routing requests to different model providers within the same environment.
So it manages the handoffs.
Exactly. You don't have to write complex, fragile API wrappers from scratch. You just tell the CLI which expert to call for which job.
Okay, so we have a specialized routed team. Let's meet the first player who kicks off this entire automated factory. Agent 1, the scout.
The trend hunter.
Right. The Scout runs on Claude, and its only job is trend intelligence. It isn't relying on its static training data from a year ago. It searches the live internet, monitoring rapidly ascending cultural moments and memes.
And it does it in real time.
Yes, and it doesn't just dump a disorganized list of links into a folder. It outputs a highly structured 5-part brief.
And that structure is the secret sauce here. The Scout is programmed to deliver a trend title, the cultural context, which is a plain language explanation of why the meme is funny and where it originated.
Crucial for a joke.
Right. Then it provides the emotional register, the trajectory of the trend, and finally a visual direction.
I have to push back here, though. If this agent is searching the entire live internet for memes, how does it not instantly drown in garbage and noise?
That's the big question.
Right. The internet is a fire hose of terrible, irrelevant, or just totally incomprehensible content.
Oh, absolutely.
Yeah.
The defense against that noise comes down to the strict constraints built deep into the Scout system prompt. The developer didn't just tell it to, find popular things.
That would be a disaster.
A total disaster. They strictly limited the Scout to returning only 3 to 5 high-confidence briefs per run. It's mathematically not allowed to give a long list.
Oh, wow. Forced curation.
Exactly. Furthermore, the prompt forces it to prioritize content that is visually translatable, meaning it has to be a concept that would actually make visual sense printed on a shirt.
So it can't just be a funny soundbite on a video because you can't print audio.
Precisely. And crucially, it is instructed to only pull trends that are currently ascending. It is explicitly told to ignore things that have already peaked.
Oh, that's smart.
Yeah, a meme that was funny 3 weeks ago has 0 commercial value today. The system is designed to catch the wave before it crests.
That is so smart. You want the trend while it's climbing the roller coaster, not while it's pulling back into the station.
Right.
So the Scout does its job. We now have this beautifully structured 5-part text document explaining a hot new ascending trend. But a text document on a hard drive doesn't give us a physical product.
No, it doesn't.
The pipeline has to actually create the art. Enter Agent 2, the artist.
The artist is powered by OpenAI's image generation model. It takes that 5-part text brief from the Scout and basically acts as an autonomous prompt engineer.
It translates the text into an image.
Right, it translates the cultural context into a visual prompt.
Here's where it gets really interesting. The artist isn't really a painter. It's more like a highly literal graphic designer. If you just walk up to an AI image generator and say, make a funny meme shirt, it will make something incredibly boring.
Completely generic.
Exactly. It needs incredibly strict boundaries to succeed.
And those boundaries are hard-coded into the artist's prompt. The developer baked in incredibly strict aesthetic principles. First, the technicals. It is instructed to generate a massive 4,500 by 5,400 pixel image at 300 dpi.
Wow, that is professional print-ready quality.
It has to be. But creatively, the prompt forces the artist to prioritize bold, high-contrast illustration over photorealism.
Why is that?
Well, because a photorealistic image usually looks like a muddy, unreadable mess when printed on fabric.
Oh, of course. It also strictly forbids the artist from including text in the image unless absolutely necessary, right? AI notoriously hallucinates spelling, so keeping the art and the text separate gives the system more flexibility with how the final product is laid out.
That's right.
But from what the developer wrote, the handoff between Agent 1 and Agent 2 wasn't exactly smooth sailing at first.
Oh, not at all. It was a massive point of failure early on. The author discovered what they called the scout-to-artist handoff problem.
Oh, what was happening?
Initially, the Scout was giving incredible cultural context. It was explaining exactly why a meme was funny on a deep sociological level. But it was giving 0 visual direction.
It's like an architect handing a builder an essay about how a house should feel emotionally but forgetting to include the blueprints. The builder is just going to build a generic square box.
That is the perfect analogy.
The AI artist needed blueprints, not just vibes.
Exactly. The artist was receiving these complex explanations of a joke and producing technically competent but creatively generic art. Abstract emotional concepts completely confuse an image generator.
Oh, so how did they fix it? Did they have to switch out the artist model?
They didn't touch the artist at all.
Yeah.
The fix was forcing the Scout to think like a creative director.
Oh, I see.
The developer went back to the Scout's system prompt and added that specific visual direction field we mentioned earlier. The Scout was forced to explicitly suggest a physical composition, a color palette, and a style reference.
Wow.
Yeah, once the Scout started providing those architectural blueprints, the artist's output improved dramatically.
Which is such a human dynamic. If an account manager gives a designer a vague brief, the design is going to be terrible. The fix isn't firing the designer, the fix is writing a better brief.
Exactly. Better inputs equal better outputs.
Okay, so now we have a trendy concept, and we have a bold, high-contrast piece of print-ready artwork sitting in a folder on a server. But a JPEG doesn't make money. How does an AI physically click buttons on a website meant for humans without getting blocked?
Which brings us to the operational bottleneck and Agent 3, the publisher.
The publisher brings Claude back into the mix, but this time Claude is paired with a browser automation tool called Playwright. For those unfamiliar, Playwright is essentially a ghost browser.
Right.
It's a web browser that runs in the background, controlled entirely by code rather than a human clicking a mouse.
The publisher agent reads the shared directory on the hard drive. And let's talk about how these agents actually communicate for a second.
Yeah, how does that work?
They aren't chatting with each other in some digital void. The Scout saves its text brief as a JSON file, which is basically a highly organized digital post-it note.
Okay.
The artist saves its image file in the same folder. The publisher is programmed to wake up, read the JSON post-it note, grab the image, and then fire up that Playwright Ghost browser.
It physically navigates to RedBubble, logs in, uploads the file, and then automatically generates a catchy title, a consumer-facing product description, and over 15 relevant tags based on the cultural context stored in that JSON file.
It navigates a live web interface to push the product out to the world, entirely procedurally.
But hold on, let me challenge the technical feasibility of this. Web interfaces change constantly. RedBubble might run an update tonight that moves the upload button 3 pixels to the left or changes the underlying code of a drop-down menu.
You do that all the time.
Right. Usually, bots navigate websites by reading the hidden background code, looking for a specific line of code that says upload button. If RedBubble changes that code, traditional web scrapers go blind and completely break. Doesn't this agent just crash constantly?
This is where the specific capabilities of the Claude model shine. Traditional automation uses hard-coded CSS selectors, those hidden lines of code you mentioned, which are incredibly brittle.
Super brittle.
But the publisher agent doesn't rely on the underlying code remaining static. At each step of the upload workflow, Claude actually takes a visual snapshot of the current page state.
Wait, really? Oh, wow. So it's actually looking at the rendered pixels with computer vision.
Yes. It looks at the screenshot, sees a giant red box that says upload, calculates the X and Y coordinates of that box, and tells the Ghost browser to click there.
That is wild.
It dynamically interprets what it sees and decides what action to take next based on the visual layout, just like a human user would. If there's a slow loading state or a minor UI variation, it adapts on the fly. It generates the Playwright automation code dynamically in real time to advance through the steps.
That completely changes the game. It's not a blind robot walking a tightrope hoping the rope doesn't move. It has its eyes open and can adjust its balance.
Exactly.
But for all this incredible visual capability and autonomy, this pipeline hits one massive solid brick wall when interacting with the real world. Authentication. RedBubble, like almost every consumer platform, actively blocks automated bot login attempts.
And this is the reality check for fully autonomous systems. The real world has gates.
Instead of trying to hack past the security or build some complex system to spoof a human, the developer designed a deliberate 30-second human handoff.
Right.
A real, live person has to log in manually just once. The system saves that authenticated session state as a file, literally naming it redbubblesession.json, which acts like a VIP wristband. The publisher then uses that saved wristband to bypass the login screen for all subsequent runs until the session naturally expires a few weeks later.
The whole pipeline is just connected by that simple shared file system and basic shell script.
But I have to ask, if a human has to intervene and log in, we can't really call this 100% autonomous, right? It reminds me of the 80-20 rule in engineering. People will spend 80% of their budget and time trying to automate that final, stubborn 20% of a task. Why not just inject credentials, write a script to solve the KPT-CHA, and force it to be totally hands-off?
This raises an important question about how we should actually design AI systems for the real world. Trying to spoof logins or hack past bot detection is incredibly fragile.
It breaks all the time.
It does. The platform will inevitably update its security And your complex, expensive spoofing script will break. Plus, it violates the platform's terms of service.
Right, you don't want your entire storefront permanently banned on day 2 because you tried to trick a PCHA.
Exactly. The developer realized that fighting the platform's security is a waste of resources. Accepting the bottleneck and using a human to bypass it is actually brilliant resource management. Designing for a clean, explicit human handoff at the highest risk friction point and then automating the 99% of the work on either side of it is the gold standard for robust enterprise engineering.
That makes total sense.
The goal of automation isn't zero human involvement at any cost. The goal is maximum leverage. A human spends 30 seconds authenticating the session, and the AI agents spend the next hundreds of hours doing the heavy lifting.
I love that perspective. It's not a failure of automation. It's a highly intentional architectural feature. So we've built the machine, we've plugged it in, we've bypassed the login. What does the final output actually look like? Well, the store is completely real. You can go to RedBubble right now and find it under the name 𝑏𝒊𝒕𝒊𝒍𝒐𝒕.
Anyone can see it.
Right. As of the writing of this walkthrough, it features 16 fully AI-generated designs. It has shirts with titles like "Delulu is the Salulu" and "Ate and left no crumbs."
Which perfectly reflects the Scout doing exactly what it was programmed to do, tracking internet slang and translating ascending meme culture.
But the developer was transparent that the system isn't flawless. We already talked about how abstract emotional concepts confuse the artist, but the publisher also stumbles occasionally. Its auto-generated tags are sometimes a bit too generic.
Yeah.
It will read the JSON file and tag a shirt with trending meme, which is technically true, but completely useless for search engine optimization because it's competing with a million other shirts with that exact same tag.
Which just proves that even with brilliant architecture, tuning the prompts and the outputs is an ongoing, iterative process. It's never just set and forget.
So what does this all mean? We have a system that is basically printing merchandise based on the bleeding edge of internet culture, but if this thing is scraping meme culture completely unsupervised, what is stopping it from accidentally pulling a copyrighted logo?
That is a huge risk.
Right. Or worse, what if a meme is trending because it's incredibly offensive and the Scout doesn't realize the cultural baggage, writes a brief, and the artist prints it on a shirt for anyone to buy?
You've zeroed in on the exact reason why the developer is actively moving this architecture from a 3-agent pipeline to a 5-agent pipeline.
Oh, they are adding more agents.
Yes. The immediate next step is to add a review agent and a marketing agent.
Tell me about the review agent.
Before any artwork or text gets sent to the publisher, this review agent will intercept the Scout's brief and the artist's image. Its entire job is to screen for intellectual property violations, trademark exposure, and cultural responsibility.
So it's a safety net.
Exactly. It will flag anything that could be considered misappropriation, copyrighted material, or harmful content. Because, as you pointed out, trend-driven content sits at a highly sensitive intersection. When you scrape the raw internet, you pull up the bad with the good.
And the marketing agent, what does that one do?
Well, once a product clears the review agent and is published, the marketing agent will take the cultural context from that original JSON file and auto-generate promotional posts for Instagram and Facebook. It will tailor the tone and the hashtags to each platform's specific audience.
Unbelievable.
What this evolution proves is a fundamental law of automation. As these systems scale in their ability to create, risk mitigation becomes the actual bottleneck. When you have a machine that can create infinite products instantly, filtering out the bad or risky ones becomes just as important as generating them in the first place.
That is such a powerful insight. Let's wrap this up because we've covered incredible ground today. We've seen how specialized AI agents, a Scout, an artist, and a publisher, working sequentially through a simple shared file system, leaving digital Post-it notes for each other, and leaning on their unique model strengths, can entirely automate complex knowledge work.
And the most important takeaway for you, listening right now, is that this architecture isn't just for selling t-shirts.
No, not at all.
What we've broken down today is a completely reusable template. You could swap out the prompts and use a Scout to monitor your competitors' pricing across the internet. You could use an artist agent to generate localized marketing copy for different global regions.
Or internal operations.
Exactly. You could use a publisher to take those insights and automatically update your internal databases. The technical barriers to building these multi-agent workflows have dropped to the point where a single person can orchestrate an entire department's worth of work right from their laptop.
It is a blueprint for the future of how work gets done. But I want to leave you with a final thought to ponder, something that really sits with me when I look at the velocity of what this technology can do. We just talked about an AI pipeline that spots a cultural trend, designs a product around it, and makes it available for purchase worldwide within minutes.
Almost instantly.
So, what happens to the entire concept of fast fashion, or even the idea of trend cycles, when there aren't just one, but thousands of these autonomous stores competing against each other in real time? What happens to art and expression when we can essentially commercialize culture the exact second it is created? When the factory has no noise and the assembly line is completely invisible, what exactly are we going to build?